All right, so take a look. Let's not be chatting back there today. Thanks. All right. If you have a line that is going up from left to right, what kind of a slope is that? Yeah, but what's the other word for it? There you go. Yeah. So if it goes up from left to right, it's a positive slope. If it goes down from left to right, it's a negative slope. Yeah.
Horizontal and vertical.
Do you need a mechanical pencil? Oh,
You can use it
you can use that one. That was fine. All right. This one here is a horizontal line. However, I'm going to write horizontal up here. Because horizontal lines still have a particular kind of slope. And it's not positive and it's not negative. What number is in between positive and negative? 0. Yeah. So the slope of a horizontal line is 0. And then there's this last one over here, which is the vertical line. And I heard the word infinite, which is like kind of, but not quite. So we got positive, negative, 0. It's one that you saw last year, but not all that often. All right, you ready? Undefined. So going up from left to right is a positive slope, down from left to right is a negative slope. Horizontal lines have a slope of 0. Vertical lines have an undefined slope, meaning there isn't a number that we can use to represent the slope. So we just say undefined. All right. Now, if you are trying to figure out a slope from a graph, for example, problem number 1, we've got point A and point B. What is the process? Does anybody remember the process? What we call it to find the slope? There's 2 words. I'll just give you that. No, we're only talking about slope right now. So we're only talking about slope. So slope intercept would be like y equals mx plus b. That would be the whole equation of the line. We don't want the whole equation of the line yet. We just want the slope. It's even more basic than what you're all thinking. All right, you ready? You're gonna look at it and you go, oh yeah. What goes on the bottom? There it is, rise over run. By the way, I'm gonna write this onto the up to the side underneath here. Always look from left to right. Basically, like you're reading. Always look from left to right. A to B on number 1. P to Q on number 2. M to N on number 3, even though that's not left and right, go alphabetically. J to K on number 4. So rise over run, always look from left to right. Because if you look from right to left, then the numbers that you get for rise and run might not be the right numbers. And if you take a look at number 1, in terms of the diagrams up above, which one does that one most closely match with? Positive, negative, 0, or undefined? Positive, yeah. So the number that we get needs to be a positive number for number 1. So to get from A to B, the rise would be the vertical change. So to go from A to B straight up would be 1, 2, 3, 4. That's up 4. And you can put this on your graph if you want to. You don't necessarily have to, but a lot of people like to do that just as a reminder. And then the run will be the left to right. So 1, 2, 3, 4, 5. So it's over 5. So that would be plus 5. By the way, the denominator, the run will always be positive because you are always going left to right. And whenever you go left to right on the x-axis, that is always in a positive direction. So the numerator could be a negative number if you go down, but the denominator will always be positive. All right, so we end up with values of 4 and 5 for the rise over run. So 4 over 5, and that is our answer, 4/5. Does anybody remember what lowercase letter we use to represent slope? What is that? M, yeah, so we're gonna say M equals 4/5. That's the answer for number one. M equals 4/5. Hopefully this looks familiar. This is stuff that we did last year. So I'm gonna speed things up a little bit with number two. So to get from P to Q, we going up or down? Down, which means this slope will be negative. And if you look up here at the negative example, it's moving down from left to right. Same with number two, moving down from left to right. So, what's that? Okay, so if you have to go down, the numerator, the top number is going to be a negative number because from P to Q is down. So this would be 1, 2, 3. That would be down 3. And if you have to go down 3, that would be a decrease of 3. So we're going to write -3. So the rise is -3. And then the run, the amount that we have to go over, is 1, 2, 3, 4, 5, 6. So that would be -3/6. If the slope reduces, we want to reduce that. So -3/6 would reduce to what? Yeah, -1/2. So the slope M is equal to -1/2. Cool. The last two here, you can just write the words associated with the type of line up top. So if it's a vertical line, like we have on number 3, what's it going to be?
Undefined.
Undefined. Yeah. Slope is undefined. There isn't a number that we can use to describe that slope, so it is undefined. How about number 4? 0. You just write the number 0 because it's the actual number 0. Because the reason why it's 0, by the way, is because it's not going up or down, and the only number that isn't positive or negative is 0. All right, next ones. 5 through 8. We're going to be talking about finding slope again, but this time we're not going to be using a graph. We're going to be using ordered pairs. We're going to use points. Have we done this already this year? I think we might have, but I'm not really sure. Can't really remember. If we haven't, that's okay. There is a slope formula. And the slope formula says, if you have 2 points on a graph and you know the coordinates of them, the slope M is going to equal, here's the formula, y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. That's the formula to find slope when you are given coordinates. So write that down, and then on number 5, we are finding the slope of line AB, where point A is at -2,5, and point B is at 6, -1. Remember that the first number in each set of parentheses is an x value, and the second number is a y value. And the first x value is x1, so -2, that's x1. The second x value, 6, is x2. We've used x1, y1, x2, y2 in this school year already with the distance formula. So then the second y, or the first y value here is y1. The second y value over here is y2. So what we're going to do is just throw those into the formula real quick, do some subtraction, simplify a fraction, and then we'll call it good after that with our slope. So we got M equals, let's see, y2 is the first number on the numerator, which was -1. So we're going to write -1 minus y1, which was 5. And we're going to put that over x2, which is 6, minus x1, which was -2. So we have -1 minus 5 over 6 minus -2. What does -1 minus 5 equal? -6. And then when you subtract a negative, yeah, it's like adding. So 6 minus -2 is the same as 6 plus 2, which is 8. Again, if you're still having trouble with adding and subtracting integer values, just grab a calculator. All right, -6/8 does reduce -3/4. So our slope here, it's a negative slope, and it's -3/4. I'm going to try the next three on your own. Try 6, 7, and 8 on your own. If you need a calculator, feel free to grab one. Okay, let's take a look at number 6. Number 6. So in terms of what you should have written, I don't have an answer up there yet. I don't have an answer yet, but I've got them plugged in. So y2 minus y1 should be 7 minus -3. And then x2 minus x1 should be -6 minus -11. So on the numerator, 7 minus -3 is the same as 7 plus 3, which is 10. On the denominator, 6 minus -11, -6 minus -11. Hey, we're going over some answers here. Thanks. -6 minus -11 is -6 plus 11, which is 5. 10 divided by 5 is 2. You can leave the denominator of 1 on the bottom if you want to, but definitely simplify it to either 2 or 2 over 1. The reason, by the way, the reason why you might want to keep a denominator of 1 has to do with when you graph these, which you will be graphing them, not today, but within the week. And I'll talk about that when we get there, but sometimes it's a good idea with slope, even if it's a whole number, to keep your denominator of 1. All right, if you got your phone out, put it away. Phone's away, thanks. All right, number 7. 2 minus -4 would be 2 plus 4, which is 6. And then 9 minus 9 is 0. Ooh, I heard 3 different answers. I heard 0, undefined, and 6. Rough. Yeah. All right. Those of you with a calculator, real quick, type in 6 divided by 0, or the fraction 6 over 0. Okay. It says it can't calculate it. So if I were to write in 6 divided by 0 here, it says divide by 0 error. If I were to type in the fraction 6 over 0, it also says divide by 0 error. If I use my giant brick of a calculator and I type in 6 divided by 0, it's a little bit hard to see. But, oh, look at that. This calculator actually gives me the real answer, which says undefined. So this one is undefined because dividing by 0 is not a mathematical possibility. You can't divide by 0, which means this is a vertical line. So we're going to say undefined. That is a vertical line. If you want to put a little note here, denominator of 0 means vertical. So we're talking about slope. If you have a slope with a denominator of 0, that is a vertical line which means the slope is undefined.
And numerator of 0 is 0.
A numerator of 0 does equal 0, which is what happens on number 8. -3 minus -3 is the same as -3 plus 3, which is 0. And then 0 minus -7 would be 0 plus 7, which is 7, which equals 0. So 0 as a numerator is 0. 0 as a denominator is undefined. So this would be, I'm going to write this over here. -3 minus -3 is the same as -3 plus 3, which is 0. Yeah. So a numerator of 0 means horizontal. So if you want to put those little notes in there, if you get stuck on some problems, you can come back and check those little notes and you can figure out if we're looking at positive slope, negative slope, undefined slope, or slope of 0. All right, so that's your quick review on slope. The rest of today's lesson is going to be talking about slopes of lines that are either parallel or perpendicular, which is stuff that you learned last year as well. So we're going to be doing a review on that too. Does anybody need more time on this first page? All right, flip it over. So we're just going to go ahead and be very quick with these ones here. It says to find the slopes of the following lines. Now you could use either method here. I'm going to just go ahead and pick a few. We're not going to do all of these. I'm going to check the answer key just to decide which ones I want to do here. So let's see. I'm only going to choose, I'll choose 2 from the top. Actually, I'll do 3 from the top, maybe even 4. Now we'll do 3 from the top and then 4 from the bottom. All right, we are going to go with we're going to go with number 3. We're going to do number 2. We can talk about it. We're going to do number 3, number 4, and number 5. Those are the 3 we're definitely going to do up top. And we can take a look at number 2 real quick as well. And then from the bottom set, we are going to look at, let's go with, let's see, 15. We're going to go with 15 from the bottom. We're going to go with number 15 from the very bottom. We're going to go with number 9. We're going to take a look at number 11. And we are going to look at number 14. So those are the 4 we're going to do from the bottom. So we don't need to do all of these. If we do want to actually just really quick look at number 2, we can do that as well. So, and I'll scoot it down so you can see which ones we need to do as well. So if you want to take a look at number 2 real quick. Let's see, if we start from this point up here, by the way, when you're figuring out slope from a graph, just find the 2 dots that are on the graph. And if there aren't dots, find out where the graph or the line of the graph goes through 2 specific like coordinates of the grid lines. And so if we start here on this dot, we go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that'll be a rise of -10. And once we head down here, it's going to be 1, 2, 3 over 4. So that'd be -10/4, which would reduce to -5/2. So that would be the slope for number 2. It doesn't equal a whole number. Oh, you mean like a decimal? -2.5? No. The reason why we don't do that has to do with when we need to graph these. Because these numbers literally mean rise over run. And so if you were to graph it, a slope of -2.5 or -2.5 would not be super nice, but a slope of -5/2 just means you're going to go down 5 and over 2 from every single other point. So converting them to decimals or mixed numbers is not something that we're going to do when we're dealing with slope. So if it's a fraction, leave it as a fraction. All right, number 3, let's take a look at this one very quickly. I'm going to be very fast with these ones. So from this point down here to this point up here, we're going to go up 1, 2, 3, 4, 5, 6, 7, 8. So a rise of 8 and a run of 2 gives us a slope of 4 or 4 over 1. You can go with the whole number 4, or you can leave it as a fraction 4 over 1. Just be careful when you're counting here because these grid lines tend to be pretty small. So if you need to double check, double count it, just to make sure. But 8/2 reduces to 4/1, or if you just have +4 with no denominator, that's fine too. All right, number 4. Anybody have that one?
-1.
-1? Yeah, why is that?
Because it's -7 and +7.
Yeah, because it's down 7 and then over 7. So it goes down 7 and then to the right 7, which would be a negative slope, and -7 divided by 7 just reduces to -1. Or you could have -1/1. Either way is fine. Number 5 is a horizontal line. You don't need to do any math here. You can just write what?
0.
Yep. There you go. So those are the graphs. Very quickly on those. Moving on to our coordinates now, starting with number 9. So remember, it is going to be, so we've got x1, y1, x2, and y2. And we are using the slope formula from the previous page, which is y2 minus y1 over x2 minus x1. So in this first example here, we're going to have m equals y2, -7, minus y1, which is also -7. So minus -7 over x2, which is 5, minus x1, which is also, which is -6. So -7 minus -7, 0. 5 minus -6, 11. 0 on the numerator means the slope of 0. That is a horizontal line. All right, number 11. Let's go to the next one. We got y2 minus y1. That's going to be 5 minus -2 on the numerator. So m equals 5 minus -2 over denominator 10 minus 10. Somebody other than Rob. I appreciate your answering, but I want to hear from some other folks too.
7.
Mabel. What's that? Undefined. Yeah, why is that? What's the numerator? 7 over 0, which is undefined. Denominator of 0 means an undefined slope, means it's a vertical line. By the way, if you recognized right away that 10 minus 10 was 0 and the denominator was 0, you can just write undefined. You don't have to worry about the numerator there. All right. Last two from this page, 14 and 15. 14, we're going to go with m equals y2, which is 1, minus y1, which is 0, over x2 -13 minus x1, which is -18. One minus 0 is 1. And then -13 minus -18. All right, let's see. 5. All right. And that's it, 1/5. That fraction doesn't reduce. Positive 1/5. So if you were to graph this one, looking at it from left to right, it would be going in an upward direction. All right, last one on this page, number 15. M is equal to y2 minus y1. So -4 minus -11 over -2 minus 1. Subtracting negatives oftentimes is going to be the part that can, be the trickiest part on these. So again, calculators are totally fine. What's -4 minus -11? 7. Yeah, just 7. Yep. And then -2 minus 1. And I would actually rewrite this as -7/3. With the negative either with the numerator or just off to the side of the fraction. Generally speaking, convention-wise, keeping a negative on the denominator isn't something we usually do. Especially for graphing purposes. You would want to keep your negative with the numerator. It doesn't change the meaning of the number, but it does change maybe how you would put it on a graph. So try to keep those negatives with the numerators. All right, any questions on finding slope? This is kind of coming back to you from last year, maybe even the year before. You might have done slope in pre-algebra too. I know we did it last year. All right, turn the page. Now we get to talk about parallel lines and perpendicular lines. This is kind of getting into the meat of the lesson here. Thinking back to last year, what do you know about lines that are parallel in terms of their slope? They're the same, yeah. Because if they're going in the exact same direction, that means they're going up at the same rate or down at the same rate, or they're both zero or they're both undefined. So same slopes for parallel lines. So basically, if you are testing the slopes of two lines and both slopes end up being exactly the same, you could say they're parallel. Next one says perpendicular lines have blank blank slopes. There are two words here. If anybody remembers those two words, that would be kind of awesome. What's that? Opposite is one of the words. It's the first word. But the word equal kind of implies parallel. And up above here, I'm going to write the word negative, but I like the word opposite. I'll give you a hint. Look at the next line underneath it. Yeah, reciprocal. Yeah. Right here. Negative reciprocals are opposite. I generally go with opposite reciprocals because the word negative implies that if it's negative, it's just going to be negative, but it's not that way. If it's negative, it's going to go to positive, which would be opposite as opposed to negative. So I like the word opposite as opposed to negative. So they have opposite reciprocal slopes. I would use the word opposite. Opposite reciprocal slopes. So opposite means you have a positive and a negative. Because if one of them is positive, the other one's negative. If one of them is negative, the other is positive. That's what opposite means. And then what does the word reciprocal mean? Mabel? Yeah, you flip over the fraction. So basically, anytime you're looking for perpendicular slopes, you have one positive slope, you have one negative slope, unless we're talking about horizontal and vertical. We'll talk about that in a minute. But you have a positive and a negative, positive slope, negative slope, and you flip over the fraction. So with example number one here, we're just looking for opposite reciprocal numbers. So for example, this is a positive 3/4. So the next one has to be negative, but you also have to flip over the fraction. So what's it going to be? 4/3. So negative 4/3. Make it negative, flip it over. If it's negative, make it positive, flip it over. The number 2 does have a denominator. What is it? 1. Anytime it's a whole number, we have a denominator of 1. So that's a positive 2/1. So we need to make the positive into a negative. And then 1/2. So opposite reciprocal of 2/1 would be negative 1/2. Negative 7/8 would become a positive. And flip it over would be 8/7. So if you have lines here with those different slopes on a graph, they would intersect at a 90-degree angle. That's what perpendicular means. Let's see, 1 is the same as 1/1. So what's the opposite reciprocal of 1/1? Negative 1/1, or just negative 1. This is an interesting situation where 1 and its opposite, negative 1, are opposite reciprocals of each other because 1 is its own reciprocal. If you flip over 1/1, you get 1/1, so 1 is its own reciprocal. So basically, you can just take opposites of it's 1 and negative 1. All right, so the last one, though, this is where the whole opposite reciprocal thing doesn't really pan out, and it has to do with the type of number we're looking at. What does 0 mean in terms of a slope? That means that, yeah, it means the opposite reciprocal would be undefined. You got it. So undefined. The reason for that is 0 does not have a reciprocal, nor does it have an opposite. The opposite of 0, there is no positive and negative 0. That's not a thing. 0 isn't positive or negative. So if you have a slope of 0, that is a horizontal line. And anything that is going to be perpendicular to horizontal has to be vertical, and vice versa. So vertical and horizontal are kind of the special exceptions when it comes to slope. So if you have a horizontal line, perpendicular to that would be vertical. If you have a horizontal line, parallel to that would just be another horizontal line. It's basically like the x-axis and the y-axis, right? It just creates that T right in the middle of the graph. So horizontal and vertical have to be perpendicular to one another. All right. Now we've got just a bunch of more examples here. We're not going to do all of them. I'm just going to do 2 from the front and then 3 from the back here. So 2 from this page and then 3 from the one on the back. No, I'm just going to pick problems that you're going to be working on. So two problems from the front and then 3 from the next page. Yeah. So let's go with 1, 2, and 4. 1, 2, and 4 from this page. We'll start there. All right. So what we have to do on every single one of these problems is figure out the slope between point A and point B, figure out the slope between point C and point D, compare those slopes, and the directions say, compare them to determine if they are parallel, perpendicular, or potentially neither. Meaning they're not the same and they're not opposite reciprocals. So let's have a look. Slopes between A and B. Here we go. Y2 minus Y1. So I'm just going to say M and then AB. Because I want to identify, I can't just write M now because there's 2 lines here. Slope means, well, which one? So that's why I'm writing AB, slope of AB. Slope of AB is going to be Y2, 6 minus Y1, 3 over X2, 2 minus X1 of negative 2. Six minus 3 is 3. 2 minus negative 2 is 4. So the slope of line AB is 3/4. So in this box over here, go ahead and write 3/4. So slope of line AB over in this box, write 3/4. Then we're going to do the same thing with CD. So slope of line CD, Y2 minus Y1, that'll be 3 minus 0 over X2 minus X1 would be 3 minus negative 1. So what's the slope of that line? Was it? 3/4 again. Yeah, 3 minus 0 is 3. 3 minus negative 1 is 4. So slope of line CD, 3/4. Exactly the same slope, parallel lines. And you can write the word parallel, or you can just go ahead and do the symbol for parallel, which is that. Any questions about what we're doing with these problems? All right, we're going to do 2 more together on this page, and then I'm going to pick 4 from the next one for you to do on your own. So problem number 2, next one. Slope of line AB. So every single one of these, we've got 2 slopes to figure out. So slope of line AB is going to be Y2, 4 minus Y1, 2 over X2, 5 minus X1, 0. So 4 minus 2 is 2. 5 minus 0 is 5. So the slope of line AB, 2/5. For CD, slope of line CD, Y2 minus Y1, 3 minus 8 over X2 minus X1, 3 minus 1. What's our slope for that one? -5. 3 minus 8 is -5. 3 minus 1 on the denominator is 2. Okay, so -5/2. What types of lines are these? Yeah, it's a perpendicular. Good. And the reason is because we have a positive and a negative. And if you flip the fractions over, you get from one to the other. So 2 over 5, 5 over 2, positive, negative. Cool. We got one more on this page that we're going to look at, then I'm going to give you 4 from the next page. Yeah, Vicky. You can write the word perpendicular. Yeah, I usually just go with the symbols because it takes less time. But if you want to write the words, you're welcome to do that. All right. Any questions here? Okay, let's look at number 4. Slope of line AB. Let's take a look. So slope of AB. Y2, 6 minus Y1, 8 over X2, 2 minus X1, -1. Let's see, 6 minus 8 is what? -2. 2 minus -1? 3. So let's see, -2/3 for slope of AB. -2/3. All right. For CD, slope of line CD, Y2 minus Y1, 3 minus 2 over X2 minus X1, 3 minus -1. 3 minus 2 is 1. 3 minus -1 is 4. Neither. Yeah. I think that one's pretty obviously neither because the numbers are completely different. However, sometimes you will end up with neithers that look like they might be perpendicular or parallel. For example, sometimes you'll get things like -2/3 and +2/3, which would also be neither because they're only opposites. They wouldn't also be reciprocal. So be careful when it's neither. Sometimes the neithers can look like maybe parallel or perpendicular when they are in fact neither. All right, turn the page. The last 4 that I want you to do here. See, I'll pick some good ones for you. Let's go with number 8. Do number 8. Do number 9. Do number 11 and number 12. So 8, 9, 11, and 12. And I'm going to give you 5 minutes. So 8, 9, 11, and 12. And we'll check back in at 8:48. And then you have a lot of work time. 8, 9, 11, and 12. Five minutes on those. All right, a couple more minutes. Yeah. Okay, here we go. Let's take a look. With problem number 8. Here we are. So number 8. There it is. Take a look. Slope of AB is -1. Slope of CD is +1. 1 and -1 would be opposite reciprocals of one another. Therefore, they are perpendicular for number 8. Any questions on that one? -1 for AB, +1 for CD. Those are their opposites. But remember, 1 and -1 are their own reciprocals, and so 1 and 1 is its own reciprocal. So just opposites there is enough to say perpendicular. It's the only case where opposites are also opposite reciprocals. All right, how about 9? Everybody get number 9? Yeah. Okay.
9 over 2 and 0 over 3.
Number 9.
Number 9, yeah.
-2/7 and 7/2.
I got 2/7 and 7/2. So -2/-7 is correct. However, if they're both negative, it means the whole thing's positive. Because a negative divided by a negative is a positive. What's that? What's that? We're number 8. Yeah, -2/-2, +1. Yeah. So -2/-7 would be +2/7. 14/4 is 7/2. These are reciprocals, but they are not opposites. So they're not the same, so they're not parallel, and listen up. They're not the same, so they're not parallel. They're also not opposite and reciprocal. They're just reciprocal, not also opposite. Therefore, they are neither. So you got perpendicular for 8, neither for 9. And then skipping number 10, going to 11. All right, so let's see. Serenity, I think you're answering number 11 for me, yeah? What'd you get? Yeah. Yeah. So 9/0 would be undefined. 0/3 would be 0.
Parallel.
Which would be perpendicular.
Why?
Yeah. Undefined would be a vertical line.
I just got to mix it up. That's all.
0 would be a horizontal line. A vertical line and a horizontal line would be perpendicular to one another. That's number 11, perpendicular. How about number 12?
Parallel.
Yeah, why?
Because they're both undefined.
They're both undefined. Yeah, they're both vertical. 2 vertical lines on number 12, parallel. All right. Nice. So we're looking at about 20 minutes, 21 minutes actually of work time. So let me get you your assignment. Hopefully that'll be enough time to get most of it, if not all of it done.